completion of the International Space Station and the retiring of the Space Shuttle program, a debate rages over the future of space exploration. Should NASA continue to focus on low Earth orbit, developing technologies for the future? Or should NASA have a goal, like it did in the 1960s with Apollo?
The way we got to the moon was by a presidential imperative that demanded that NASA get to the moon within a decade. So NASA was forced to sit down, design a plan for how to do that, and then fly the mission. Since that time, without the presence of a driving imperative, we engage in basically a random set of constituency-driven programs which are justified ad hoc afterwards by the argument that they could prove useful at some time in the future when you actually have a plan to go somewhere.
I think NASA has focused on a steady process where the government can't just pull the plug on their funding. I think the Apollo cancellation was very traumatic for NASA, and it really transformed NASA from what it was in the 60s to more of what it is now. If you have a singular program like going to Mars, then it is very vulnerable to having its funding pulled.
NASA must be destination-driven. It is the only thing that allows the agency to be productive. NASA was 100 times more productive when it was destination-driven than in the period that it has not been. And we have stagnated in NASA since 1973. 30 years, more than a generation, has been wasted. The American space program's been stagnant for 30 years. There's a once-in-a-generation shot right now to get it moving again by giving it a goal that'll take it somewhere. So the stakes today are high. And if you ask me if I am nervous right now, I am.
Dr. Zubrin.
Why is NASA stuck in low Earth orbit? The problem with NASA's lack of current achievement is not money. The problem is lack of focus, it's lack of a goal. It shouldn't be humans to Mars in 50 years. It should be humans to Mars in 10. We can do this. We do not need gigantic nuclear electric spaceships to send people to Mars. That is pork, it's nonsense. The primary question I get from the American people is, why aren't we doing this? There's a big sense of disappointment, almost verging on a sense of betrayal. The purpose of spaceships is to actually travel across space and go to new worlds, not to hang out in space and observe the health effects from doing so.
Dr. Zubrin, in your testimony, you were very passionate on it, but you also were mad. You're mad we haven't done this, or that this vision has been stolen from a generation?
I guess you could say that. It's like Columbus coming back from the New World and Ferdinand and Isabella saying, so what, forget it, burn the ships. Okay, that's what has happened in this country. We've won our point that there needs to be a destination. The point we need to win on now is that the destination needs to be Mars, and it needs to be soon.
The movement to send humans to Mars in the near term began at the University of Colorado in 1978. A graduate student in astrogeophysics named Chris McKay gave a small seminar on the possibility of introducing life to Mars.
I got interested in Mars in graduate school. I entered graduate school the same year that Viking landed on Mars and sent back these images, and it sent back data that showed all the elements needed for life are here on this planet, and yet there's no life here. I thought, oh, that's odd. It's sort of the lights are on and nobody's home. And I thought, well, that's curious. So some of my other grad students and I, we sort of got together to talk about, well, if there's no life on Mars now, could we put life there? And that evolved also into the question, well, maybe there was life in the past, and we could find fossils, evidence of it. Well, how would you do that? Well, you do that by sending people there.
Together with fellow graduate students, the group decided to put together a small conference to discuss the matter of human Mars exploration.
We basically just started a forum. We invited everybody from all the NASA centers and from all the universities that were involved in it, and they all came. And it really was In retrospect, I realized a very important step toward building a consensus for human exploration of Mars.
In 1996, I published my first book, The Case for Mars, and the response was phenomenal. I got 4,000 letters from all over the world. I had Parisian bankers and 12-year-old kids in Poland and firemen from Saskatoon and astronauts, and they're all writing me and saying, how do we make this happen?
Bob Zubrin came to the third Mars conference and got very much involved. And he was willing and interested in forming a society, forming a group and organizing.
He said, look, if we could pull these people together, if we can get them to work together, we could have a force that could actually make humans to Mars happen.
The group formed the Mars Society. Robert Zubrin became the president. They held their first convention in 1998.
The convention was just magic. We had no idea how many people were coming. They were there not just from the United States and Canada and Europe. They were there from Israel. They were there from Mozambique. They were there from New Zealand. It was astonishing.
Since its inception, the Mars Society has attracted members worldwide. Derek Shannon is the head of the Southern California chapter. He's met with political leaders from all over the country.
If you make them look at the whole Mars vision in historical terms, it becomes a much easier sell. How will the Martians remember our century? They're probably not going to remember our deficit, our wars, our healthcare. Those will be footnotes. What they'll remember is that out of all of human history, there came a generation that decided to take this amazing step out into space. And if you tell politicians that they're the ones whose names actually get to be remembered, that's when, hopefully, the space program starts going somewhere.
In order to further the knowledge necessary for a manned mission to the Red Planet, the Mars Society has been building research stations around the globe, all of them based on the design of Zubrin's HAB module. Most recently, the Society set up a desert research station in Utah. Here, international researchers and aerospace students come to do experiments under the harsh desert conditions and learn what's necessary to keep a Mars crew alive and productive.
Basically, what we're doing here is undergoing analogue studies. Crews of up to 6 people at a time come together to live in a full simulation environment for up to 14 days. So what that means is every time we go outside the HAB, people have to don spacesuits. They have to depressurize. When we go outside, they're called extravehicular activities. They can only be of a certain duration due to the air supply. We have to recycle all our water and basically have our own food as well.
It's great to fantasize, but it's another thing when you have to put it together, when the nuts have to fit the bolts.
Like the Apollo missions to the Moon, sending human beings to Mars will mean putting people in harm's way. There are many dangers in outer space, and many things could go wrong. A serious equipment breakdown could doom the crew to their deaths. Some argue that the risk of failure is simply too high.
You know, back in the days when medieval man was looking out from Europe and thinking about exploring the world was unknown, and map makers populated their maps with dragons. We've got the same thing today. There are people who are afraid to go out into space, and they've populated their maps of the solar system with dragons. You know, we've got cosmic radiation, we've got zero gravity, we've got back contamination. But these are dragons that we can take on.
There are 2 kinds of radiation astronauts must contend with in outer space: solar flares and cosmic rays. Solar flares are floods of protons that burst from the sun at irregular intervals and would be dangerous to an unshielded human crew.
We are not ready to send humans to Mars right now. We've got to know a lot more about radiation and radiation mitigation. One of the Apollo flights barely missed, like by a week, a major solar event. If it had gone off when the Apollo astronauts were on the way back and forth to the moon, they would have gotten their entire lifetime radiation dose in that one mission. And that's just one solar flare. So that's why we worry about this.
In the Mars Direct plan, Zubrin envisions a central insulated core where a crew can retreat to while the radiation passes by. The core would be surrounded by all the provisions of the mission. This should